Hi everyone, welcome to the discussion. So this is a calculus based question and let's get into it without any delay. Right, so here a glass is given, a flask which is spherical in its bottom and it have a cylindrical neck oval. And initially the flask is empty and we are pouring a liquid into the flask and that rate is given over here. That rate is at the rate of 2 centimeter cube per second. And okay, so when we pour the liquid's height will rise, right? And volume of the flask will rise. So there is a change in volume and the liquid's height, right? So the volume V centimeter cube is given. It's not the flask volume, it is the volume with respect to the height, right? When we are pouring, the height will increase. That particular volume is equation is given. Volume of the liquid at that moment. So whenever the height is, we can substitute it over here. So this is the one. And next one, these are the information given. Now we need to find the rate of change of the height of liquid. Of course, the height will change, right? When we start pouring it continuously. Exactly at the moment when volume is 200 centimeter cube, what will be the rate of change of the height of the liquid? So that's it. Let's interpret into the math language. So we are pouring a liquid into at the rate. So it is the rate of change of volume, which is, we can mention this as dV with respect to time, right? That is, we are transferring it. So dV by dt is 2 centimeter cube. Per second. This is the one. And we have to find rate of change of one volume is given to us that we can use. Rate of change of height means what? So we can interpret this particular thing as dH by dt. I need to find with the condition when the volume is 200 centimeter cube. So this is what we have to work for, right? So, but height function is not given to us, right? Volume function is given. So let's start with volume, which is 5 pi h square minus 1 by 3 pi h cube. Let me differentiate with respect to t. Okay, V is made up of h, but I'm going to differentiate with respect to t. Apply the implicit differentiation. Differentiate, because that is what we are dealing with. With respect to time, what's the height? I want somehow dH by dt should be formed. And h is not given to us. So this is the only way. Differentiate V with respect to t. So h is a function of t, right? So how we can do? dv over dt is equal to 5 pi is a constant and h square normally you will differentiate, which is 2h, but it is not a d with respect to h differentiation. Since it's with respect to t, I have to multiply dh over dt. If you see t square is just 2t, but since it's h square and we are differentiating with respect to t, this have to be included. This is a must. Then minus 1 over 3 is a constant, like pi over 3 is a constant, and h cube, same process. H cube normal differentiation is 3h square. I am differentiating with respect to t, so I need to add this dh over dt. Right? This is important. We should not make any error over here. And right, so dv by dt equal to 5 pi this. Okay, I know dv by dt, what it is. It's 2 centimeters, so I can just substitute and I can start simplifying further. So 2 is equal to 10 pi h dh by dt minus, let me cancel out this 3, which is minus pi h square dh over dt. My aim is dh by dt, right? So I can frame the equation from here. Take dh by dt common and I will get 10 pi h minus pi h square this side too. Okay, what is dh by dt then? Just transfer this over here, and dH by dt is equal to 2 over 10 pi h minus pi h square. That's it. Okay, now that's it. So we are almost at the important part. dH by dt is found, but I want the rate of change of height of the liquid when volume is 200. Okay, so volume is 200. Let me substitute. Okay, the condition is when V is equal to 200. At that moment, we need. Okay, so when V is 200, what is H? If I find that, I can substitute here and I can find the rate of change, right? So let's start. And we know the V equation. V is like, it's directly given to us, 5 pi H square minus pi by 3 H cube. And you just equate it to 200 is equal to 5 pi H square minus pi H cube by 3 or whatever. Right, now we need to solve. Let's switch to the calculator and solve this one. We can use numerical solve will not be the good choice. We can go with polynomial. So let's consider this a polynomial, and polynomial root will be the polynomial equation solution, right? Let's apply that particular stuff here. Okay, so go for calculate. Go for algebra and choose the polynomial tools. You can choose real roots. That will be good. So polynomial roots of whatever the equation we got. So don't put it as an equation, make it a polynomial. So 5 pi h square, 5, and here pi h squared minus, okay, when we are inputting the fraction, we need to be careful. Pi h cubed by 3. Let me use the bracket. Wait. Pi over 3 just okay. So pi over 3 and then h cube. Otherwise, it will be calculated as pi over h power 3. Right. And equals, sorry, minus 200. Actually, we won't use the stuff minus 200, right? So let's go with pi by 3 h cube, comma, h is a variable in this polynomial. So put a comma. Let's do the change, comma, h. And we got list of values. So selecting which value, so that matters here. Let's take this over to the solution part. Here is the screen. Right. So my h is going to be, and also they have mentioned here, I won't take negative since h is positive. So 4 or 14, that is the thing in our mind, right? So this is the only valid solution because we won't consider 14. As in the question they have mentioned, you may assume that the liquid didn't reach the neck of the flask, right? So this might be the top height. So we can ignore it. Let's start solving this. So the middle value is taken here, right? So my H is 4.21 approximately, right? Next, that's it. So dH by dt is what I want, and I have this. I have H now, so I can substitute and find this value. So dH by dt is, we can substitute and then we can switch the calculator. So in place of H, I'm going to replace 4.21. That's it. 4.21 whole square. That's simple. Let's get back to the calculator again. Let's solve this part. Here we go. So we are solving almost like 2 divided by use the bracket and then 10, it's pi times 4.21 is what we have selected, minus pi 4.21 square times, again for this a bracket, 4.21 and a square. Right, so 10 pi times 4 and 2 divided by. So this is what we need to solve with the enter. We got 0.026. Let's take this value. And we can get back to the solution page. It solves. This is the solution we got. Okay, we can approximate dH by dt as is approximately 0.0261 centimeter per second. It's a height, right? So centimeter per second. So this is a solution. The rate of change of height when the volume is 200. That's simple it is. And thank you for listening. Let's meet in the next video.